Okay, a very good day to you wherever you are, and welcome to the penultimate Ask Me Anything of PLDI 2020. I'm delighted today to be interviewing Doug Lea on your behalf. As an introduction, it suffices to say that if you've used software today, you've probably used software in which Doug has played a core part, from DL malloc to concurrency and hotspot, aka the JVM. Doug, hello.
Hi. Hi.
Thank you for joining us. Thank you for agreeing to this. I'm not sure it's going to be a grilling, if I'm honest, but I'm sure it's going to be an interesting chat. I would like to start, Doug, with a simple question that I think will help frame some of what will come next. Could you give us a brief overview of how you got into computing generally and programming languages specifically?
Wow, that's a hard story. Like a lot of people who got out in the 80s, I really did not want to be doing what I was doing, and I wanted to do other stuff. And so almost all of us who were involved in sort of systemsy OO were previously doing other things. I had been doing some real-time, some cognitive modeling, some two-dimensional data structures, and then decided, hey, wouldn't it be great to start writing libraries? And that's the story of 1985 on.
Thank you. Okay, that is a really good introduction. I'm going to start with a question from John Wickerson, who says, I spent some time some years ago wrapping my head around DL malloc, and I found I could only manage to do so after drawing lots of colorful diagrams of how the memory is laid out. Did you use similar graphical aids when programming, or could you just look at your C code and know that it was correct?
You know, I know that question was coming, and I did not know how to answer it. That's really cool to ask me the first one, but I'm going to give it a shot.
Good, thank you.
Yeah, so if you design algorithms sort of for a living, which is what I think of myself more than anything else, you steal ideas from everywhere, and you try to understand them, and so you make some pictures, you write an assertion here and there, I have a long history of writing down random things on a pad of yellow quadrille paper, like my entire life. And so, yeah, there are many pictures and many little code snippets that I think maybe someday I'll use this. Yeah.
Is this like a writer's book, you know, where people are writing down little bits of poetry or something, or and then you come back to it and realize, quick, everyone, this could be the next, you know, $1 billion idea.
No, this one sadly is on fall reopening course scheduling.
Okay. Put away your checkbooks, everyone.
Yes, the story of our shared lives these days.
So how do you differentiate amongst those? How do you filter across them?
Ask that again, sorry.
How do you select, you know, you've come up with all these ideas. How are you filtering them later?
Yeah, I don't know. You know, I think one of the characteristics of people who think of themselves as library authors is we're just in the middle of everything. We're above programming languages, above hardware, below where most application programmers are thinking. And so you need to know an awful lot of the constraints surrounding you, which is why I have a lot of friends who are much better at formalisms and hardware mappings and things than I am. And I rely on my friends to be working on those aspects and try to synthesize. You know, the broader you are about that, the more you realize how uncreative you are, right? It's like, I'm very conscious that, like, I don't invent anything. I just steal good ideas from everywhere.
Well, isn't that genius? Sort of mediocrity steals and genius steals. Or I can't remember what the quote is, but I think you're doing the right one. So let's move on to another question. This one's from Sophia Drusopoulou. And again, you might have been peeking, so it's a little bit of cheating going on here, but I promise we'll find some others that you don't know later. Is there a concurrency model, e.g. actors, threads, and locks, that you think works best for particular tasks, and can you say which?
Yeah, it's actually one of my favorite questions from one of my favorite people. Thanks, Sophia. Yes, my main claim to fame in concurrency is I have no religious fervor whatsoever. I do think that if you're solving data structure problems, you should buy into divide and conquer parallelism to the extent you can for parallelism, and non-blocking synchronization for memory control. I think that's just what you should do. If you are doing things that are extremely I/O bound, I think if you can get your head wrapped around reactive programming, you should do it. It will always win. And if you want to do something that is more approachable, you should just use a lot of threads and learn and ask us to map them for you, which is what's coming up in the near future.
So you've segued, and I didn't mean to read these in order, but you've segued perfectly into a question from Peter O'Hearn, which is, have you ever met a concurrency optimization that you didn't like?
No. I do, on the other hand, box myself into corners where some things are intentionally slower to be nice.
Nice in what sense?
To be nice. So a good example is we have a concurrent hash map, the most well-used concurrent frame component in the world, maybe. And it, to be nice to people, because people have trouble coping otherwise, when you do a compute if absent, it will lock the mapping so that nobody else can interfere while you're constructing that. And so there's a guaranteed lock. It means that if you want to do speculative construction, well, we have a method for that too, and it's faster. But this one is intentionally slower, and in fact, the desire to support it really influenced the design of the whole data structure. Is that we wanted to make sure that in some cases we could lock a mapping.
So when you say nice, that the example you've given there is trying to make it more difficult for people to shoot themselves in the foot from a correctness perspective?
Yeah, it's because it's pretty hard if you're doing compute if absent and the computation is it takes a lot of cycles or uses a lot of space, you really don't want to do it more than once. Even if, secondarily, you can get confused about side effects and do something just plain wrong.
So there's the second aspect then of if you're trying to make sure that people get the performance that they hoped for, even if they perhaps aren't always exactly aware of what they're doing and perhaps aren't doing what you would like them to do in an ideal world. So you're trying to find a trade-off between these two. Is that a big part of your job?
Yeah. Trying to guess what people like, regardless of what they say they want, is a tough call in API design. Like every kind of requirements, people don't know what they want. And I don't necessarily know better what they want either. But I talk to more of them than talk to among themselves. So I generally have a better basis for making that trade-off. Still, the main danger here is that everybody who's ever made an API has made an API design mistake. And you only know it, you know, sometimes a day later and sometimes a decade later.
How is your approach? This is a question from me, because it's something I find very interesting. How has your approach to designing APIs changed over time then? Because it was something when I was younger, here's a library, deal with it. And then so I've got less immature, let's say, I've realized that the experience of using a library is changed massively by the API. And I don't really know what to do with that thought sometimes.
Yeah. I am much more constrained than the people designing languages. Right? The people designing languages, they're all about expressivity and making things convenient. And I'm in the, oh, I found something interesting to me and sort of hard that I'm willing to do for you. And so we're a little bit a captive of the language we're in. Good thing JVM languages are so diverse, so that you can usually find a language that'll match like better than Java, for example, in a lot of cases. But some of them are big surprises. It was a surprise to me that adding lambdas has such a big impact on plain parallel computation through parallel streams and more reactive styles through completable futures. Without lambdas, neither of those was something that people wanted to do, even though we had put together prototypes of a parallel bulk operation. If you don't have lambdas to work with, it's just like, it's no fun. Completable futures, same deal. If you don't have a lambda to shove in there, they're just no fun.
So Sophia is mentioning on the Slack channel that she's reminded of McCarthy's story of introducing garbage collection to make the system more beautiful. And it sounds there that you're saying that lambdas have made it possible to create more beautiful or at least better APIs. And how much does that cause you a backwards compatibility issue, in the sense that you've got older APIs that don't use it that you wish did, and people who are coming to it fresh and not going to know the difference?
Yeah, there are glitches on the right now. The glitch that I'm working on is that we have many ways of doing message passing, that none of which say they're message passing APIs, and as lighter weight threads are going to be supported upcoming in the Loom project, and like, we really want to have a nice unifying form where you can mix and match sort of Go CSP Erlang style stuff and reactive streams with subscribers with async actions. And I'd like to give people like a mature unifying view of all of that, because not only am I completely not religiously fervent about all this, my biggest enemies are the people who are religiously fervent about all this, and I really want them to grow up.
So are you trying to make a demilitarized zone, or trying to bring peace to them in some other way?
Yeah, I'm trying to make something that will have some of the impact that we saw with like Lambda on divide and conquer parallelism. Like before there were parallel streams, nothing much was different. You could create fork join tasks. They ran really fast. They were like competitive with most other platforms, if not better. But you had to at least have done really well in your algorithms courses to understand how to go about it. And as someone who teaches algorithms courses, commonly, I don't think, I think it's sort of fun to do that by hand, but nobody else does. So the whole parallel stream part, it brought a lot of dangers. It brought a lot of people saying, oh, this is easy. I think I'll try to, parallelize adding 10 numbers up. And of course they get, this constant factor slowdown just to start up the computation. But we survived that pretty well.
Cool. We've got a number of questions asking in variations about formalization and correctness. And I'm going to take Peter O'Hearn asked us a sub-question, but I think now it makes sense to ask. He says, have there been cases where you left a potential optimization out of your code, like Java util concurrent, either because you couldn't convince yourself of its correctness or incorrectness, or have you always found a way to convince yourself of the correctness of the optimizations you put in?
Yeah, this is another one I knew was coming and didn't have an answer. So just watch me.
See, you shouldn't have cheated. Then you wouldn't have known how difficult it would be.
It's definitely the case that I've had optimal, faster ways of doing things that I conditionalized to the places where they actually worked. So in that sense, no, I've never thrown them out unless they were broken anyway. If they didn't apply ever, they're just not there. I do rely on people doing formalisms of all sorts. I don't know, people doing memory models, verification, just specification, languages and the like. I think all of that is needed, and the hardest part of working with any such people is that there's a little bit of an arms race here, where to get performance, most of what I do is relax invariance. To get verification, most of what they do is strengthen invariance.
That is a very interesting way of looking at it. So you're saying to some extent that the two are in tension. Are they? Is it an intolerable tension or an unresolvable tension, or is there a sweet spot?
No, it's all good, but it's a career. It's not a project, right? So.
Okay, well, actually, then let's ask a question from Guy Steele, which may relate to this. We're asking, do you have any opinions about the current state of model checkers, proof checkers, and the like, especially with respect to verifying concurrent algorithms?
Yeah, my opinion is I have not ever met a model checker that I didn't like. Now, and usually the conversation ends up with, oh, and if you could handle this case someday, some decade, that would be really great too.
And is it a case of finding the right one for the right job? And do you have any intuition about which one in advance, or do you just wait till they blow up and then try another one? Or
well, I actually like threat sanitizer and that genre a lot. Mm-hmm. We actually have in Java util concurrent, we are TS clean. We have annotations for everything that confuses it, and so that part works well. It's a small subset. The hope is that we can get more routine checking of all of the relaxed atomics, because those just keep increasing in frequency and
complexity as well, I imagine.
Yeah, and so there's a lot of hope on that front too. I mean, the people at Max Planck love them all because they are pushing harder on getting models that are close to what we really want. In a sense, Paul McKinney is sort of my alter ego, right? He's got my role in the Linux kernel, And both of us are big fans of all that work. Yeah.
So do you ever use, and this is a question from Sophia again, do you ever use formal notation yourselves, or are you always working with other people to verify the code?
Yeah, almost always somebody will have their own notation, and I will help them. Like, I will validate that they captured what I think is most important to check.
I see. Are there certain notations that you've found easier to work with or a natural map, or do you find it's just it's just surface syntax, it doesn't really matter too much?
Yeah. Pass.
Oh, I have found a question. Ah, okay. There's a weak spot. Okay. Where do I want to go next? There's one here from Stefan Ma. Assuming that people mix and match concurrency models to solve their problems, do you think there are major issues with correctness when they're doing that rather than just using one in isolation? If so, what could be a way forward that would harmonize these concurrency models and make them safer?
Well, I gave a little bit of the answer, is I'd like to have a story about message passing-ish stuff that does allow you to mix and match at least sort of the thread-based and the reactive-based factions. That's not so hard to do. When you do it in practice, it's like really not so hard to do if you know what you're doing. This is why I rely on people who are into language design and expressiveness and the like, because I make no pretense about that. Like, I was literally surprised that lambdas made such a big difference in Java.
You're speaking to a failed language designer. I learned, having designed a language, that I have absolutely no sense of taste, which I could have realized by looking in the mirror each morning. But it takes a certain type of person, it seems to me, to really work through the ideas there and filter them out. And I agree with you. I wouldn't have put a bet on lambdas in Java really taking off. But clearly they've made a huge difference. So yeah, who knows how these things happen. Where was I going to go? Okay, this question I like a lot. It's from John Wickerson again. Is the future bright for transactional memory?
Well, a little bit of a historical aside. When practically everyone else I knew started working on transactional memory, I started working on lightweight parallel execution engines. I remain a huge fan of 2CAS, 3CAS, that is very small granularity, atomic instructions supported by hardware, that if you had, many problems could be solved and people could make other frameworks on top of it. And I think had those people had less ambitious aims, the world would be a little better right now. That if every processor had supported like just sort of minimal transactional multiple cache line stuff, then we could rely on it and we could build more and better things. Of course, life is not like a bunch of transactions. Not every nail wants the same hammer. And so I have the same point of view about transactions as I have about, lock-based code. There's great lock-based code. Non-blocking code, there's great non-blocking code. I often mix and match them. The concurrent hash map story is like 50% blocking and 50% non-blocking, and it's a good trade-off. And if I had, simple, fast, optimized over the period of years, minimal transactions, life would have been better. Instead, it's going nowhere, right?
Seems that way from my perspective as an outsider.
Yeah.
And do you think that's because of the difference in between vendors, or just that the idea, never quite managed to meet the promise, and so it wasn't really applicable to enough problems?
Yeah, it is a little bit of, I think, religious fervor just being the root of all evil in concurrency. You know, saying, you know, let's, like, we have transactions, let's just put them everywhere, make people think in terms of transactions. Wouldn't the world be a better place? And I immediately, you know, like checked for my wallet to see if somebody is like sticking me up here.
That's a good analogy. Let me move. So not everyone watching will be aware that you're really straddling academia and industry in a way that's almost unique in my experience. So I've got a good question here from Yulia Belyakova. In your teaching experience, what concept, and she asked, you know, perhaps specifically concurrency or perhaps not concurrency, which concept is the hardest for students to pick up? And do you have any tricks for getting it across to them more quickly?
Yeah. In first set of courses I regularly teach, I teach year-long sequences as concurrent parallel network distributed programming. I regularly teach the junior level algorithms course, and I trade off occasionally teaching the PL and compiler courses. And each of them I could tell you something that is hardest, sometimes just because it's hard to get right. So nobody can get like pointer rebalancing and balanced trees right the first time, right? Like nobody has ever done so in the history of mankind, right? It's like, so there are some things that are just so error prone, people get them wrong. And no matter how you teach them, no matter how clever you think you are in making sure that this time when I present it, they can't possibly get it wrong, they do.
And is this the standard problem that the abstractions are hard to get, or is there some, is this because they're unifying several areas, or?
Oh yeah, you know, there is a common theme, and that, you know, part of the common theme is that people do not understand semicolons very well.
You mean when writing English or writing programs?
It's really easy. Like what happens with with like red lectures and the like is you forget you've already reassigned one of the fields, and then you just get wrong. So aliasing is sort of, you know, aliasing is another thing for which I have, you know, amateur standing in the academic circles, and it's because of things like that. Aliasing, really hard to give up. In my concurrency course, I tell them day one, well, most of this course is trying to make you unlearn all of the things that other people keep teaching you, and that part is hard. It's the concepts are hard, and made worse by some of the ways to express them are intrinsically play into people's weaknesses. So
could you give us an example of one of those?
Well, like aliasing again.
Right.
Like, aliasing is a very hard thing for humans to see. And I'm really thrilled that the world has made like a lot of progress in doing that. And, you know, and if we taught our intro students to program in Rust, they would probably make fewer of those mistakes, but we don't do that.
Well, that would introduce another interesting thing that they'll to challenge them over. There's no easy path, it seems to me, or we would have found it, I assume. I mean, is that? I mean, do you feel that we're evolving better systems overall, or that we're just sort of moving the mud around?
You know, there are days when I feel cynical and I think we're just, you know, moving the mud around. But my whole outlook on life is that we're making things better, and sometimes we make things worse because of unforeseen consequences. But the intent is, you know, I'm just an aging hippie. You know, I just try to like make the world.
Thank you. Okay, we have a question here from Zheng Lu, so going back to some of the technical stuff. Do you think that message passing is better than shared memory in terms of bugs and readability? And should we be rewriting shared memory programs into message passing ones?
No, no. I think that coherence is strictly more powerful substrate to work on than a message passing substrate. And why in the world would you give up the power to use all those transistors that the nice people building memory controllers have put in? You know, I have nothing against message passing programs. And, you know, when I teach the second half of our sequence on networking and distributed systems, that's all we do. But everything is weaker. If you do not have an atomic operation, then instead of CAS, you know, you use Paxos or something. It's like, who wants that? If you don't have to get a invent your own consensus protocol, why would you do that?
So, and this maybe is a sort of overarching with several things that we've talked about. You know, you've talked about trying to find this sort of intermediate ground between these different styles, but we've done so, I think, in an assumption of JIT compiled systems. Obviously, you spend a lot of time in the Java world. What are the pros and cons that you see of taking that as one of your constraints? You know, you're working within Hotspot versus if you were compiling to C++ or Rust or whatever.
Really good question, because I have a lot of crazy code sitting in the bowels of here and there that is there because I am working with an idiot savant compiler, right? All JIT compilers, they do some things really well, and they are just really expletive deleted stupid about everything else. And yet you cope, right? Yet I cope. So there are constructs, there are lines of code here and there where it's only a line of code or two that's been sitting there unexplained, and I don't want anyone to touch it.
It's a here be dragons sort of thing.
Yeah. So there are cases where you just cope with that, and you know it's why the people who write Rust libraries and JVM libraries and C++ libraries, we all implement similar ideas, and our code doesn't look anything like the other cases.
But is that, do you mean from a sort of surface level, or do you mean in terms of the APIs, or the internals are the same and they're exposing a different API? Or
well, you would program in a language where you have dynamic compilation, you have you know, speculative compilation of hot paths, things like that. There are things that if you know that's the platform you're on, you should code to it. Mm. Why wouldn't you? This is my extended response to Peter. Right? It's like, right? Why wouldn't you make this faster?
That's a very good, very reasonable point to make. You mentioned you called the compiler an idiot savant in terms of JIT compilation. Do you occasionally wish that you were in the static compilation world then?
Yeah. Yeah, there are a bunch of cases where I really want C++ templates.
Can you give us an example? A simple one for an idiot like me, preferably.
Well, there's just a fair amount of like boringly redundant, nearly redundant code sitting in completable future, for example, right, that we do because we do not want to take the hit of creating a closure object and evaluating it. And so we just stretch out all the functional forms we're going to deal with and do not intertranslate among them. And that just adds clutter. It means that I should mention the person, one of the people I cannot live without, Martin Buchholz. He's sort of our release engineer for Java Util Concurrent. He's a Google employee, and he is so good at helping test and capture and code review the 17 different variants of the same code for me, because I can make cut-paste hack mistakes. I've been known to do it.
I'm astonished that anyone would do that. Yes, I've never made a copy and paste mistake. Not today. Yeah. So is it there that you're trying not to cause a code explosion for the dynamic compiler partly, or is it just that the language lacks the feature? I mean, no reason that Java couldn't have.
Right. It lacks compile time evaluation in the cases where I really, really would want it, and so I compromise and do it myself. So
we have a quick follow-up here from Stuart Marks. So would you prefer templates in a C++ style or macros? And let's assume that scheme style macros or something like that. Do you have a preference on this hot political and religious topic that divides nations?
Yeah. Well, I would love, a versions of macros that Rocket has. I would take those. Scheme, style, enhanced from there. It's, there's every language has something to really love about it, and they do that so well.
That's very true. That is very true. I certainly learned an awful lot from that system. I want to, we're getting towards the end, and but I wanted to just ask a final question, which is, what will be, you said what you're working on now, what do you hope to work on next? And what's your sort of, not your end goal, because there is no end in programming, it's an everlasting grind. But if there's one thing that you could achieve in the coming years, what do you think it would be in a technical perspective?
Well, I live a happy life because I never do make that plan. That's my final answer too. I am in a place where, in theory, when there's not pandemics and a million other things, in theory, I can wake up every morning and say, I'm just doing something completely different. And I almost never do, but but I like the feeling that I could. So, yeah, I refuse to answer.
That is actually the best answer that I think you could have given. Doug Lea, thank you so much for doing this. It's been an absolute pleasure. I can tell from Slack that people have really enjoyed listening to your answers, and I'm sorry for talking a bit too much probably at some points, but I hope that we've been able to have a good discussion, and good luck with everything. We'll look forward to seeing what you do next. Thank you again, Doug.
Okay, thanks. Bye, everyone.